Hello, my name is Daniel. Welcome to the channel. This is for explaining what Standard Young Tableaus are. Standard Young Tableaus. And young is not an adjective, it's a name because it was discovered or made by somebody called Young. Right, and now in this problem, I've brought the problem number 17 of AMC 12 from the year 2010. Right, this asks for basically the number of Standard Young Tableaus in a 3x3 array. Right, and what Standard Young Tableaus are, they are just like grid formations, like these ones, right, like that. Those all kinds of tableaus, so things like this. So these grids, that would also be considered a tableau. But a Standard Young Tableau, that is when the entries in every row and column are in increasing order. That is basically what a Standard Young Tableau is, right? The way to just making a Standard Young Tableau, that's very easy. That's just put 1 in the first corner, that's just inevitable. And we have 2 and 1 of 2. So let's say this is 2, and 3 would be either here or here. So let's say 3 is there. And so I'm filling out the same thing. So filling out the rest, that will be just 4, 5, 6, 7, 8, 9, 10. But then now we want to know the number of possibilities of the Standard Young Tableau. So what I mean is we want to find the number of Standard Young Tableaus that are in this configuration. So in the AMC video, I said that the number of Standard Young Tableaus, SYT I'll say, this is the number of entries, of which is n factorial, over the product of the hook numbers. Now I'll explain more in detail what this is. Okay, so hook numbers, they are, so let's say that this one, let's choose that one, and the hook number for that entry, for that square, that will be the number of entries to its right and to its down, including itself. So to its right this much, and to its down that much. So the number of grids, number of squares in here, that will be its hook number. Because it looks like a hook, that's why it's called that. So this hook number will be 3. Then the hook number for this one, that's just this thing, so that will be 1, 2, 3, 4, 5, right? So the hook number for that will be 5. The hook number for this, that will be 1, 2, and because there's nothing on it, so that will be 2. So those are hook numbers. So it's n factorial over that. Hook numbers, they are not just limited to these just 3x3 grids. Hook numbers are present in any kind of tableau. So let's say we have this kind of tableau, then the hook number for that one would be, so that would include these 3, right? So that would be 3. So that would be 3. And the hook number for this one, that would be just these 2, so it's going to be 2. And the hook number for this one, that's just going to be, this is nothing, so that's just going to be 1. And one more, the hook number for this one, that would be that much, so that has 6. So it's 6, like that. So those are what hook numbers are. And now let's kind of take a look at these hook numbers and use them for this one, for the 3x3 grid, use them to kind of prove this. So it's not a perfect proof, but then still does the job, and it gives this result. We have a grid, a 3x3 grid, as mentioned in the problem. First of all, the way to put all the digits from 1 through 9 inside here in any random order, that doesn't have to be a Standard Young Tableau. So random order, that would just be 9 factorial, right? Because we have 9 ways, we have 9 numbers to put in there, 8 numbers to put in there, 7 numbers to put in there, and so on, right? So that's going to be 9 factorial. But then for this to be a Standard Young Tableau, if we have a entry, that entry has to be the least number out of all its hook numbers, right? So say this number has to be less than every number in its hook number. Let's just rephrase that for here. So here, this colored part has to be the smallest. So out of these 5 numbers, the probability that this one is the smallest, that's just, the probability of this is just 1 over 5. So that's 1 over 5. And the same thing for every other cell. So if we have that one, then the probability that this is the smallest, that the green one, this is the smallest, is just going to be 1 over 4, because it has 4 numbers in its hook. So its hook number is 4, and so it's going to be 1 over 4. It has to be the least out of those 4. Same thing for this one, that's just going to be probability that this one is smallest. It has to be smallest out of the 3, so this is 1 over 3, and so on, like that for all of these. Yeah, for all of these, same thing for all of those 9 squares. And so if you notice, then these numbers, those numbers are the hook numbers for each cell, because this is like literally that is the number of things that are in and on its down, right? So this is the hook numbers. So these are all hook numbers. And so now we get that the probability for this to be a standard Young tableau, this is going to be equal to anything, so the random order, 9 factorial, multiplied by all of these multiplied together. So it's going to be 1 over 5 times 1 over 4 times 1 over 3 times 1 over 4 for this one, and all the way until we have all the hook numbers, until we have all its hook numbers on the denominator. And so this is going to be same thing, 9 factorial over all these hook numbers, 5, 4, 3, 4, 3, 2, 3, 2, 1. This is literally the n factorial over the product of the hook numbers. So that is what this is the same as. And so that is why this is the total number of standard Young tableaus. And so if we get finished with this problem, this is going to be equal to n, there's 9. So this is going to be 9 factorial over this much. So it's 5, 4, 3, 4, 3, 2, 3, 2, 1. So it's all over 5, 4, 3, 4, 3, 2, 3, 2, 1. All over 9 factorial, which is 9, 8, 7, 6, 5, 4, 3, 2, 1. So that's going to be, if we can cancel out these, then we can cancel out these two, and then we can cancel these, like that. And now finally we will have 2 and 3, so this will be 3 times 2 times 7, which is 42. And so that means we have 42 standard Young tableaus in this configuration. That's why the answer is 42. It's D. So thank you for watching, and I hope this has helped you, and I hope my explanation wasn't so confusing, and thank you for watching.